Hi, welcome to my video on the sector of a circle. O is the center of each circle that I'm going to do. I always put O as the center. Sector of a circle is a region bounded by two radii and an arc. So if I name this point F and this point H, what we have here is a central angle O. FOH is the central angle, and the central angle is made up of two radii with the vertex at the center. So a sector is a region or area bounded by the two radii OH, OF, and the arc FH. We also have another one here, and we can name it A and B, 2 points on the circumference. And a sector, this is a minor arc, so we could have the other part of the circle, which is this part. It's still a sector because it's bounded by two radii and arc. But this arc, the arc is, let's name this T here, ATB. So the arc is ATB, so the area of the sector is, this is an angle less than 180, so this sector is more than 180, major arc, but it's still the area of the circle. And the sector is a part of the area of the circle. So let's do some examples. What part of each circle is the sector? Well, the sector has a central angle of 80, and also the arc from here to here has a measure of 80. So if the arc has a measure of 80, then the central angle has a measure of 80. So it's the central angle over 360. 360 degrees is all the way around. So cancel out the zeros by dividing by 10. 4 into 8 goes 2. 4 into 36 goes 9. So the area of this circle, like a piece of pie or a pizza, is 9/10 of the whole area of the circle. And we have another sector here, and this arc here is 120 degrees, the same as the central angle. So that means that this angle here is 240 degrees. So this angle from here to here is 240 degrees because it's 360 degrees around this point as one rotation. So that means this arc is 240 degrees. So the central angle is 240 degrees, and that's what part of the total rotation. Again, divide by 0, and we can we got a 240 degrees. So we divide by 12, so that's a 2 and a 3, so that's 2/3. So this sector is 2/3 of the total area of the circle. This sector here must be 1/3, because 120 over 360 is 1/3, so this part is 2/3 of the area of the circle. Okay, let's continue. And I got number 1 and 2 here, so for numbers 1 and 2, we're going to find the area of the sector in terms of pi. And again, O is the center of the circle. So the formula for the area of a sector is the central angle over 360 times the area of the circle, which is pi r squared. Theta is the central angle, and r is the radius. So we have a figure here. We have the arc AB. So the arc AB is 60 degrees, and OA is 6 centimeters. OA is 6 centimeters, which is the radius. O is the center. That means that OB is 6 centimeters. So since the arc AB is 60 degrees, then the central angle, so the angle AOB is 60 degrees because the central angle is the same measure of the arc. So that means the area of the, I'm going to put sector in brackets, the area of the sector, formula is theta, which is the central angle over 360 times pi r squared, which is the area of the circle. So the area of this sector, central angle is 60 degrees over 360 pi, and the radius is 6, so it's r squared. And we reduce that down. 60 into 60 goes once, 60 into 360 goes 6. And we got 6 squared here, so I scratch that 6 and take off the square. I got 6 left, so I have the area is 6 pi. And since the radius is centimeters, so the area is square centimeters. So 6 pi square centimeters. Number 2, we have a diagram. We have the circumference of the circle is 8 pi inches, and we have angle P. Let's put on a G right here. Angle PGF, this angle G, is 50 degrees. And we want the area of the sector that's shaded. So this is the shaded region. So POF bounded by this arc PF and the 2 radii. We want to find the area of this sector. So the circumference is 8 pi. The circumference of a circle is 2 pi r. Therefore, that 2 pi r is equal to 8 pi. The pi's cancel. So divide by 2, r is equal to 4. And again, it's 4 inches. So let's see, we want the central angle. So this is an inscribed angle bounded by 2 chords and a common, the vertex is on the circle. So this is an inscribed angle. So the inscribed angle is half the measure of the arc. So this angle here is 50. So the arc PF is 100, double it. So this angle is half the arc, or the arc is twice the angle. So since the arc is 100, the central angle right here is 100 degrees central angle. So the area of a sector is theta, central angle, over 360 degrees pi r squared. So that makes the central angle 100 degrees over 360 pi, and the radius is 4, so it's 4 squared. So reduce that down, and let's see, cancel the zeros, so they're divided by 10, and we could have 2 into that goes 5, 2 into that goes 18, and we have a 4 here, 4 times 4, so we got a 5 and a 4, so let's take the 4 squared and make it 16. So because they're even, we'll divide by 2 and make that a 9. We divide by 2 and make it an 8. So we have a 5 pi 8. So that's a 40 pi divided by 9 on the bottom. And because it's in inches, then that's square inches. We want the answer in terms of pi, not as a decimal. So we leave pi in our answer. 40 pi over 9 square inches. Now we have another problem. Let's have a look here. The sector of a circle has an area of 4 pi meters squared and a radius of 3 meters. Find the length of the sector's arc to the nearest tenth. So here now, we have an area of a sector and we want to find the length of the arc. So we have the radius. So we have the sector, got an area, 4 pi. Radius is 3. We got to find the arc length. So let's see, the area of a sector. So the area of a sector is theta over 360 pi r squared. But the area of the sector is given as 4 pi meters squared. So that means that we have theta over 360 degrees pi r squared is equal to 4 pi. And the pi's cancel out, and we can put, we have theta r squared over 360 equals 4 over 1. Cross multiply, and I get the radius. Let's put the radius in here, and the radius is 3. So if I fill in 3 right here, 3 squared, So I have theta times 9 over 360 degrees equals 4 over 1. 9 into 360 goes 40, and we cross multiply, so theta is 160 degrees. Theta is 160 degrees. Now we need to find the length of the arc. So the length of the arc is theta over 360 degrees 2 pi r, because the arc length is a part of the circumference, and the circumference is 2 pi r. We found theta to be 160 degrees over 360 degrees 2, and we want it to the nearest tenth, so okay, pi, and the radius is 3. So we reduce, cancel out the zeros, dividing by 10. 4 into 16 goes 4, 4 into 36 goes 9, and we have 3 into 3 goes once, 3 into 9 goes 3, so that gives us 8 pi over 3. Now that's the answer in terms of pi, and again the length, so that's in meters, but we want it as a decimal. So that decimal, when you take 8 and multiply by pi and divide by 3, you will get approximately to the nearest tenth. It says to the nearest tenth, you get 8.4, approximately to the nearest tenth of a meter. And again, you can time 8 times 3.14 divided by 3 will give you 8.4 when you round it off to the nearest tenth. So in this question, I combined the area of the sector along with the arc length. And the last one to do, we have a circle here, and this is the shaded region. Oh, let's see, O is the center of the circle. Okay, it says that OT is equal to OP. It says that HP is 2 centimeters, so this is 2. The diameter is 12. So we have the diameter is 12, and we have angle P is 60 degrees. So this is a 60-degree angle right here. And my diameter 12. So let's see, we have 2. Those 2 are equal. So if those 2 are equal, that means that if OT equals OP, and that's 2, then AT must be 2. And the diameter is 12, so D equals 12. So the diameter twice the radius is the diameter is 12, so the radius is 6. So the radius is 6 centimeters. So that means OH is 6. That means OA is 6 because the radius of a circle are equal. Now we have, if these of OP equals OT, and that's an isosceles triangle with 2 sides equal, that means that the base angles are equal. So this is 60, this angle is 60. 2 sides equal, angles opposite those 2 sides, this one and this one, are equal. 60 and 60, 120. So that means the angle O is 100. Angle O. 2 of these are 120. This angle is 60, 60, 60, 60, 180. Notice we have an equilateral triangle. So that means TP is 8. We didn't need it. That's 6 and 2 is 8. That's 6 and 2 is 8. That's 8. We got an equilateral triangle. But we want the area of the shaded region. So we have all the information in here. And let's see. 2 angles are equal. Okay. So the area of the sector. Let's see the area. Let's get the area of the sector. The area of the sector is theta, central angle over 360 pi r squared. So the central angle is 60, so 60 over 360, and it's pi, and the radius is 6 squared. So we worked that out, and we got 60 divides into 60 once. 60 into 360 goes 6. And we got 6 squared and a 6, so we cancel the 6. That's the 36, so we just cancel the square. So we get 6 pi. So the area of the sector, and it's in centimeters, so it's centimeters squared. Now, the shaded region is the triangle. So we take the triangle and subtract the sector. The sector is OAH, so the sector is made up of AOH. The sector is AOH. Sector is this region right here. So let's find the area of the triangle. So the area of the triangle is OTP. The area of the triangle is, we got 2 sides and an included angle. So the area of the triangle is a half of AB sine of the included angle. And because we have a circle, we have a half of R times R sine of the central angle. So that's the same as R squared sine theta. So I remember it's the 2 sides, product of the 2 sides and the included angle. But because we got a circle, then we can say R squared. So we have a half. Radius of the circle is 6. Or radius of the circle is 6. This length is 2. So the triangle has a side of 8. So it's 8 squared. And it's the sine of the central angle, which is 60. Okay, so that's a half. That's 64. Now the sine of 60. So what happens when you're dealing with a triangle and you got a 30 and a 60 angles? So this side is n, this side is 2n, opposite of 60 is n root 3. So sine is opposite over hypotenuse. So the sine of 60 degrees is opposite, which is n root 3 over hypotenuse 2n. So the n's cancel out. So for the sine of, in any 30, 60, 90 root triangle, the sine is always root 3 over 2. So 2 into 64 goes 32. This 2 into 32 goes 16. So we have, take that equal away there. So we have everything canceled out. So we have, that's 1, that's gone. 16, 2 cancels. So 16 root 3 centimeters squared. So the shaded, the area of the shaded is the area of the triangle, subtract the area of the sector. So the area of the triangle is 16 root 3. The area of the sector is 6 pi, and that's all in centimeters. So that's the exact area. Notice the exact area means you don't change your root. You leave it as root 3, and you don't change your pi. So that's the exact area. 16 root 3 subtract 6 pi square centimeters. Finding the area of the shaded region. And that brings us to the end. And again, if you like my video, click the like button, click the subscribe button. If you wish to subscribe to my channel, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.